Dear students, today we will solve some more problems on inverse trigonometric functions. The question is, write the following functions in the simplest form. Write the following functions in the simplest form. Okay. In that, the first question is tan inverse of cos x divided by 1 minus sin x. Tan inverse of cos x divided by 1 minus sin x. Whenever x is greater than minus pi by 2, less than pi by 2. So now we have to express this inverse trigonometric function in the simplest form. How can we simplify this? That we shall discuss. This is equal to tan inverse of, say, our aim is to simplify, right? We are asked to write this in its simplest form. So what we should do is try to express this, as we have tan inverse here. Try to express this in terms of tan of certain angle, so that then later on you can use tan inverse of tan y equal to y. That formula we can use. So we should try to bring this in the form, we should write this as tan of certain angle. Okay. For that, I will write cos in terms of sine, which can be written as sine pi by 2 minus x. Cos x can be written as sine pi by 2 minus x divided by this sine x. I will write it as cos pi by 2 minus x. Okay, as we know, sine theta is equal to cos 90 minus theta. Cos pi by 2 minus x is equal to sine x, and sine pi by 2 minus x is equal to cos x. Further, tan inverse of this looks like sine theta. Say, here I would like to use this formula, the submultiple angle formula. Sine theta is equal to 2 sine theta by 2 cos theta by 2. 2 sine theta by 2 cos theta by 2. This is obtained from this formula. Sin 2a is equal to 2 sin a cos a. In that, put 2a is equal to theta, then a is equal to theta by 2. That will give you sin theta is equal to 2 sin theta by 2 into cos theta by 2. Okay. So here I want to use that formula. In place of theta, we have pi by 2 minus x. So you have sin theta. I want to write sin theta as 2 sin theta by 2. Theta by 2 means pi by 2 minus x divided by 2. Theta by 2 into cos theta by 2. That is pi by 2 minus x by 2. Divided by, in the denominator we have, it looks like 1 minus cos theta. For 1 minus cos theta we have a formula. 1 minus cos theta is equal to, do you know what is the formula for 1 minus cos theta? That is equal to 2 sin square theta. 1 minus cos theta is equal to 2 sin square theta by 2. That formula I am using here. So 1 minus cos theta can be written as 2 sin square theta by 2. So 2 sin square theta by 2. Theta is pi by 2 minus x. So theta by 2, which is pi by 2 minus x divided by 2. Okay. Next, I will continue here. This is equal to tan inverse of, now 2 gets cancelled. This will become sine pi by 4 minus x by 2 into cos pi by 4 minus x by 2 divided by denominator will be sin square pi by 4 minus x by 2. That's equal to. So here sin pi by 4 minus x by 2 gets cancelled. We have cos pi by 4 minus x by 2, and here one of those sin pi by 4 minus x by 2 gets cancelled, and the other sin pi by 4 minus x by 2 will remain as it is. So cos by sin will give you cot. So that means we get tan inverse of cot of pi by 4 minus x by 2. See, I told you we want this in the form tan inverse of tan y, but we have got now tan inverse of cot y. So what do we do? Write this cot in terms of tan. Cot theta in terms of tan, one way is 1 by tan theta, which is of no use in this question though. The other method is writing cot theta as tan 90 minus theta. Tan 90 minus theta is equal to cot theta. That I am using here. Tan inverse of tan 90 minus theta, which means pi by 2 minus theta. What is theta now? Pi by 4 minus x by 2. Okay. So let us simplify that. That's equal to tan inverse of tan of. So on simplification, pi by 2 minus pi by 4 plus x by 2 we get. Pi by 2 minus pi by 4 will become pi by 4 plus x by 2. So tan inverse of tan pi by 4 plus x by 2, it looks like tan inverse of tan y. Tan inverse of tan y is equal to y. So this is equal to pi by 4 plus x by 2. This is the simplest form of this expression. Tan inverse of cos x by 1 minus sin x. So we have simplified it as pi by 4 plus x by 2. Okay. Let us look at the next question. Tan inverse of root of 1 plus x square minus 1 divided by x. Tan inverse of root of 1 plus x square minus 1 by x, x not equal to 0. Okay. So here we have to make a substitution. The question is saying you have to express it, write this in its simplest form. Before we go for simplification of this, let me explain when we have to substitute these trigonometric functions, or for what kind of expressions do we need to substitute the trigonometric functions. See, if you come across root of a square minus x square, if this expression is there, then the substitution is either x equal to a sin theta or x is equal to a cos theta. Whenever you have this expression root of a square minus x square, then in order to simplify this, we have to make a substitution as x equal to a sin theta or a cos theta. So why we are making this substitution only? Why not tan theta or cot theta or secant theta, etc.? Is because if I take x equal to a sin theta, then a square minus a square sin square theta we have. If I take a square as common, you will have a square into 1 minus sin square theta. 1 minus sin square theta is cos square theta. Root of a square cos square theta will become a cos theta. Then the simplification will be easy. Similarly, same thing will happen if I substitute a cos theta also. But if I substitute anything else, say if I substitute x as a tan theta, then you have a square minus a square tan square theta. Taking a square common will give us a square into 1 minus tan square theta. But for 1 minus tan square theta, we don't have any formula. So substituting that is not advisable. Whenever we have this expression, the substitution is either x equal to a sin theta or x equal to a cos theta. Then if you have root of a square plus x square, if you have root of a square plus x square or x square plus a square, then the substitution is either x equal to a tan theta or x equal to a cot theta. Why do we substitute this? Because if I take x as a tan theta, you have a square plus a square tan square theta, a square into 1 plus tan square theta. 1 plus tan square theta will give you secant square theta. Root of a square secant square theta will give you a secant theta. In the same way, if I substitute a cot theta, we will get a square plus a square cot square theta. Taking a square common, you will have a square into 1 plus cot square theta, which is equal to a square cosecant square theta. Root of that is equal to a cosecant theta, and further it can be simplified easily. Okay. Then, if you have root of x square minus a square, then the substitution is x equal to a secant theta or x equal to a cosecant theta. Because now if I take x as a secant theta, we will have a square secant square theta minus a square. Taking a square common, we will have a square into secant square theta minus 1. Secant square theta minus 1 can be written as tan square theta. Root of a square tan square theta will give you a tan theta. So remember this, whenever we have these expressions and these are the substitutions that you have to make. Okay, which we have already given you through that notes also. In that also it is mentioned that for these expressions, these are the substitutions that you have to make. Okay, now coming back to this particular problem. Here we have tan inverse of root of 1 plus x square minus 1 by x. Look at this expression, there is root 1 plus x square. Root 1 plus x square means you can compare with this, that 1 can be written as 1 square. So a will be equal to 1, root of 1 plus x square. Then the substitution is x equal to a tan theta, which means a is 1 here, so we get put x, we get x equal to tan theta. That is the substitution we have to make here. So put x equal to tan theta. That will imply that theta is equal to tan inverse x. Okay. So that expression will be tan inverse of root of 1 plus tan square theta minus 1 divided by tan theta. I am taking x as tan theta. So then tan inverse of 1 plus tan square theta, as we know, it is equal to secant square theta. Root of secant square theta, I'll write it as secant theta minus 1 divided by tan theta. Secant theta minus 1 divided by tan theta. Okay. Further simplification we have to do. So see here we have tan inverse of something. So I want this in terms of tan, so that we can use tan inverse of tan y formula to simplify this in such a way that this expression is in terms of tan. So this is equal to tan inverse of secant theta. Secant theta is 1 by cos theta minus 1 divided by tan theta. I write tan theta as sin theta by cos theta. That's equal to tan inverse of, take LCM here, cos theta is the LCM, that cos theta, this cos theta gets cancelled. Then the numerator is 1 minus cos theta, denominator is sin theta. Then 1 minus cos theta is equal to 2 sin square theta by 2, which we have discussed in our previous problem also, and in first quiz also, of course. Then sin theta, you can write it as 2 sin theta by 2 cos theta by 2. Okay, 2 gets cancelled, sin theta by 2, sin theta by 2 gets cancelled. We are left with tan inverse of, here sin theta by 2 is remaining, in the denominator cos theta by 2 is remaining, sin theta by 2 divided by cos theta by 2 is equal to tan theta by 2. Tan inverse of tan theta by 2. Tan inverse of tan theta by 2 is equal to theta by 2. What is theta? Theta is tan inverse x. So, the simplest form of the given expression is 1 by 2 tan inverse x. Okay, now let us go to the next question. Question is same, express it in the simplest form. Okay, let us look at the next expression, which is tan inverse of 1 by root of x square minus 1. Tan inverse of 1 by root x square minus 1 whenever mod x is greater than 1. Cannot be equal to 1 because denominator becomes 0. So, mod x should be greater than 1. Tan inverse of 1 by root of x square minus 1. Okay, so we have to simplify this. Here we have to make a substitution. Root of x square minus 1 is there. So that can be compared with root of x square minus a square. Earlier I have told you that when we see root of x square minus a square, the substitution is put x equal to a secant theta or x equal to a cosecant theta. So here a is 1, hence I will make a substitution as x is equal to a secant theta. A is 1, so secant theta. X equal to secant theta. If I substitute, then I am getting tan inverse of 1 by root of secant square theta minus 1. Root of secant square theta minus 1. Secant square theta minus 1, we know it is equal to tan square theta. Root of tan square theta. Root of tan square theta is tan theta. 1 by tan theta is nothing but cot theta. I will write cot theta as tan pi by 2 minus theta. Okay, cot theta can be written as tan of pi by 2 minus theta. That's equal to, see here we have tan inverse of tan y. Tan inverse of tan y is equal to y. So that will give you pi by 2 minus theta. What is theta? See here we have made a substitution as x is equal to secant theta. Therefore, theta must be equal to secant inverse x. So you have pi by 2 minus secant inverse x. You can write this much, or else you can also write this as cosecant inverse x. Because you know secant inverse x plus cosecant inverse x is equal to pi by 2. This is the simplest form of this expression. Let's go to the next problem now. Tan inverse of root of 1 minus cos x divided by 1 plus cos x. 1 minus cos x by 1 plus cos x less than 5. Okay. So now this is equal to tan inverse of root of 1 minus cos x. It looks like 1 minus cos theta. For 1 minus cos theta, we have a formula which is 2 sin square theta. 1 minus cos theta equal to 2 sin square theta by 2. Well-known formula. Similarly, for 1 plus cos theta also, we have the formula which is 2 cos square theta. Now, 1 minus cos x, I will write it as 2 sin square x by 2. divided by 1 plus cos x is there, that will be equal to 2 cos square x by 2, which is equal to tan inverse of root of 2 gets cancelled, sin square x by 2 divided by cos square x by 2, that will be tan square x by 2. That's equal to tan inverse of root of tan square x by 2 will become tan x by 2. Tan inverse of tan x by 2 is equal to x by 2. That's all. This is the simplest form of this expression. Next question. Tan inverse of x divided by root of a square minus x square. Tan inverse of x divided by root of a square minus x square. They are given the condition that mod x is less than a. Okay. So now you can observe root of a square minus x square. When you see root of a square minus x square, the substitution, as I have already told you, is x is equal to a sin theta or a cos theta. Let us go for a sin theta. Put x equal to a sin theta. This will imply that sin theta is equal to x by a, and which means theta is equal to sin inverse of x by a. Okay, let us substitute now. We get tan inverse of x. X is a sin theta divided by root of a square minus x square can be written as a square sin square theta. A square minus x. X square is there. In place of x, I am substituting a sin theta. So that will give you a square sin square theta. That is equal to tan inverse of a sin theta divided by root of, I will take a square as common, then you will have a square into 1 minus sin square theta. Okay, that is a sin theta divided by root of a square cos square theta, which is equal to tan inverse of a sin theta divided by root of a square cos square theta can be written as a cos theta. This a gets cancelled. Sin theta divided by cos theta is equal to tan theta. So you have tan inverse of tan theta. Tan inverse of tan theta is equal to theta. Tan inverse of tan y is equal to y. So tan inverse of tan theta is equal to theta. What is theta? Theta is sin inverse of x by a. Next question. Tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. 3a square x minus x cube divided by a cube minus 3ax square. A greater than 0. Then minus a by root 3 less than or equal to x less than or equal to a by root 3. X is in between minus a by root 3 and plus a by root 3. This we have to simplify. We have tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. Here I will make a substitution as put x equal to tan theta. Put x equal to a tan theta. Okay, that will imply that tan theta is equal to x by a, which implies theta is equal to tan inverse of x by a. X equal to a tan theta. Therefore, tan theta is equal to x by a, and theta is equal to tan inverse of x by. So that expression, given expression will be tan inverse of 3a square into x. X is a tan theta minus x cube. X is a tan theta, so x cube means a tan theta whole cube divided by, in the denominator, a cube minus 3a into x square. 3a into x square. X is a tan theta, so x square is a tan theta whole square. That is equal to tan inverse of 3a square into a tan theta. That will become 3a cube tan theta minus here a tan theta whole cube, that will give you a cube tan cube theta divided by a cube minus 3a into a tan theta whole square. A tan theta whole square will become a square tan square theta. Already 3a is there. 3a into a square tan square theta, that will become 3a cube tan square theta. Now I will take a cube as a common factor in the numerator as well as in the denominator. Then that a cube gets cancelled. So we will have tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. This is a well-known formula, that's equal to tan 3 theta. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta is equal to tan 3 theta. Tan inverse of tan 3 theta is equal to 3 theta. Okay, 3 into what is theta? Theta is tan inverse of x by a. So 3 tan inverse x by a. This is the simplest form of this expression. Okay, with that we will stop our today's class. We will continue in our next class. If you have any difficulties, please don't hesitate to ask. Thank you.